All right, guys, welcome back. So in the last video, what we did was we refactored our code to include an update method within our ship that detected whether or not a user was hitting a certain key, in this case, the left, up, down, or right arrows, and moved the ship accordingly by just simply incrementing or decrementing some internal properties about its position in space. So its X and Y coordinates. In this video, we're going to extend on this small game here with the idea of enemies. So we're going to bring some enemies onto the screen. We're going to first describe what an enemy is, and then we're going to update and draw them. So this pattern that we keep going through, right? So far we've done it twice. We've described a ship and we've described a bullet. In this case, we're calling it a bullet. It's more like a laser gun. We maybe call it a laser or something like that. But in this case, we have a bullet and we have a ship, right? And a ship has the ability to hold a collection of bullets, and bullets are spawned or created, or in the object-oriented terms, instantiated when a user hits the space key. And that's symbolized right here. That's in the draw function, right? So we're saying ship.fire when you hit the space key. Now, let's go ahead and let's start to describe what an enemy actually means. And this should be pretty simple at this point, because this is going to be the third time we're doing this. And we're now going to let's go to the bottom of our script, right? And we're going to put all classes in one file. Typically with a big project, you split this out into different files and stuff like that. But we're learning, so it's okay to do this. So let's go ahead and let's describe an enemy. So the first thing we want to do is whenever we're talking about describing something or creating a blueprint for something, we're going to make it a class, right? Because we're using kind of this object-oriented mind frame right now. So first I'm going to comment here and say, all right, let's go ahead and describe an enemy, right? And now let's say class capital E-N-M-Y, right? We want to always name our classes with a capital letter first. This kind of tells us as readers of the code that this is an actual class that we can instantiate or spawn into something else, into an object, right? Now the first thing we want to create, what is the first thing we want to create? Think about that for a second, right? The enemy needs to know how to build itself. And when we talk about object-oriented programming, we're talking about a constructor. The constructor allows us to build ourselves. So I'm going to go ahead and make a constructor, and the constructor is going to be able to position itself at some X and Y coordinate. Right? So I'm going to type constructor, and I'm going to give it two parameters, X and Y. All right? And I'm going to say this dot X equals X, and this dot Y equals Y. Now in the next videos, we're going to start talking about what's called a vector, right? And a vector will basically encapsulate this X and Y, these X and Y properties. But for now, let's just keep it simple, and we're going to make this just like we did with the ship, where we have this internal X and Y property. Now, an enemy pretty much should, I guess we could just keep it really simple, and let's just make these bad boys a square, right? So an enemy needs to know how to draw itself, just like the ship did, and just like the bullet did, right? So we're going to create a draw method. And now that draw method is going to draw something. So why don't we make it, I don't know, let's make them blue, I guess. So we'll make fill blue, and then we'll just draw a rectangle at some coordinate. And that coordinate will be this dot X, this dot Y, and then we have to give it some width and height. So we'll make it 20 by 20. We'll see how that looks. All right. So now our enemies can construct themselves and they can draw themselves. Same exact pattern that the actual ship was doing and the bullet was doing, right? Nothing new here. What we want to do now is maybe similar to what we did with the ship, right? Where we created this update method. We want to describe how the movement of an enemy should behave. And let's keep it really simple. We don't want to get crazy. Like, we're not going to do any crazy pathfinding algorithms or anything like that, and like try to get them to, attract to you with attractors and stuff. All that stuff is really exciting to explore, and I would definitely recommend doing that, and maybe I can do some of that in the future. But for now, let's just go ahead and let's create an update method. And in that update method, I'm going to just basically say what enemies do is they just move down the screen. That's it. They just move down the screen. So moving down the screen in a P5.js sketch on the canvas would actually be incrementing the Y value, right? Because remember, the origin point 0, 0 is in the upper left-hand corner of the screen. So all we're going to do here when we call update, we're going to say this dot Y plus plus. Now remember, this is shorthand for saying this dot Y equals this dot Y minus 1. Same exact thing, right? And actually, I'll keep it like this for simplicity's sake, right? And I'll just put a comment in here that it's the same thing as saying this dot Y. Whoop. Actually, we don't, I'm sorry, not minus 1, plus 1, right? This dot Y plus plus. Okay, so now we have an enemy. We have an enemy that knows how to draw itself, and we have an enemy that knows how to move itself through an update function, right? And maybe it may be clearer if we call this update move, but for now, let's just keep it update. Okay, awesome. So now we have an enemy, but how do we actually use this, right? What do we do here, right? So what we have to go ahead and create enemies. So where are we going to actually create the enemies? There's a bunch of different ways we can do this. But why don't we do this? Why don't we say, hey, as we draw, let's go all the way back up here. Let's go to our draw function, because this function keeps getting called over and over again. And we can use an internal variable. There's an internal variable called frame count. The frame count is going to give you the frame number that we are on, right? And this is getting called 30 times a second. So every second, the frame count is going to go up by 30. So at frame 2, frame count would be 60, right? At frame 3, 90, etc., right? We would keep going up and up. What we can do is we can use that variable that keeps incrementing as an indicator for when we should spawn a new enemy, right? This is just thinking about this out loud here and just, seeing if we can figure out a little method or a little algorithm to define when we should create a new enemy. So the first thing we need to do is we need a place to actually store the enemies. So this is going to follow the same exact pattern as the bullets in the ship, right? The bullets in the ship are this, right? What is this again? What do we call what that is? That's an array, right? An array. It's basically a list of information. That's all it is. So we need a list of enemies, but we're going to need these enemies to be kind of global to the entire game. So just like we have the ship up here, we're going to say let enemies equal, and we're going to have more than one enemy, right? The ship is a single thing. We only have one ship in this game, but we're going to have multiple enemies. So we're going to let enemies equal a new empty array or an empty list. So now in the draw function, right below maybe where we kind of set the background black every frame, why don't we say this? I'm going to say if the frame count, and I'll describe this in a second, it's mod 100 equals 0, then we'll create a new enemy. Now, what the heck did I just do there? I said if frame count mod 100 equals 0. Now, mod is a special type of mathematical operation. You may have learned it in grammar school. It may have been put to you as a different way. It's a remainder, right? If we have a remainder, if something doesn't divide into something evenly, we're left with a remainder. So typically, if 2 divided by 2 is 1, right? 4 divided by 2 is 2, right? 3 divided by 2 or 2 divided by 3, I should say, is not a whole number. So there's some remainders there, right? So all we're saying here is every 100 frames, spawn a new enemy, right? So basically around every, 3 or 4 frames, we should see enemies spawn. okay? That's all we're doing. We're basically using this little trick to say, hey, on X amount of frames, every X amount of frames, create a new enemy. And how we're going to do that is we're going to say enemies dot push, right? Because we're going to push a new item onto this list, and then open parentheses, new enemy. And now we're going to give it some random X coordinate, but we're going to give it a fixed Y coordinate. Because remember, we want them to come down the screen, right? So we're going to give it a random X. I'm going to say random, we'll say window width, right? Because we want to randomize where it comes on the width of the screen, and then we'll always generate it off the screen at a -10 Y position. We'll see how that looks. So now every 100 frames, we're going out and we're actually creating a new enemy. Awesome. Now, after we do that, now we want to actually draw those enemies. So outside of that conditional statement, we're going to draw them. Now, before I do that, let's go ahead and just run this code just to make sure we don't have any crazy syntax errors, and it still actually works. We're not going to see anything happen with the enemies yet because we're just generating them. We're not drawing them yet, but the program should still work. If it's not working, you can go in there and inspect and go to your console, and you shouldn't see any errors that are coming up on the console here, right? You shouldn't really see much going on here. We are writing some console.logs here, but other than that, there shouldn't be any errors. All right, awesome. We're looking good. So now, next thing we need to do is now we need to loop through every single one of the enemies we generated, update them, and draw them, right? So I'm going to use a little for loop for that. I'm going to say for let I equal 0. And then I'm going to say, we're going to loop for as long as we have enemies, right? So I is less than enemies.length, right? And we're going to increment I by 1 every time we loop. I'm going to open those curlies, close those curlies. And now all we need to do is to draw the enemies. We're going to say enemies sub I, right? Because we want to index the array. So we're picking a certain item on the list. Enemies sub I dot update, right? Because we want to call the update method. And then we're going to do the same thing. Enemies sub I dot draw. So now we're updating and drawing those enemies. So now at this point, we should see enemies being spawned every 100 frames, and they should just kind of scroll down the screen, right? So if we go back here, we look at how these are being spawned, right? They're going to be a blue rectangle, and they should just come down the screen every time we call that update function. So let's go ahead and refresh this, and let's see what happens. Oh, there's one. Oh, there's another. And there's another. And they're just going to keep on coming, right? Now, notice we have that little stroke that goes in there, and everything then gets a stroke once we fire. We can fix that. Not a big deal. But you can see here that we are now having enemies, and they are spawning. Now, we don't have any collision detection, so nothing is going to happen when we hit these guys. But we do have this pattern of an enemy coming down the screen. Awesome. So I'm going to stop there. In the next one, we'll go ahead and do a little algorithm to figure out if we're doing collision detection or not, and see what we can detect when a laser actually hits the square. But I want you to think about that a little bit. How would we do that? We have a list of lasers, right? Or bullets in this case. We have bullets. All these bullets are stored in this bullets array in the ship. Each one of these bullets has an X and Y coordinate, right? We also have a list of enemies. And this list of enemies, each one of those has an X and Y coordinate. So all we really have to do is loop through all of the bullets in the ship and loop through all the enemies, which we're already doing here. and then test whether or not those two are within some bounds, within some distance. So we have to actually just do a little bit of math to do a subtraction between the distance between those two. And if they're small enough, then we have to tell the enemy that the enemy is dead, basically, right? You got hit. You got hit by the laser. You got hit by the bullet. All right, so that's really all we have to do collision detection. But think about that for a second, and we'll come back and we'll do it together. All right, thanks.